Welcome back, folks. In today's class, I'll continue with the Newton's law of gravitation. And this is the question given in front of us that there are three bodies, Moon, Earth, and Sun. They are aligned in a linear direction. From the linear direction, I mean to say they are in one dimension. In this case, given to us in a horizontal on a horizontal axis. So that becomes a problem of one dimension, and moon is trying to pull earth towards itself, sun is trying to pull earth towards itself, and we wanted to find out the net gravitational force exerted by moon and sun on earth. That's what we are looking for. Let's first of all find out the gravitational force between the earth and the moon. So Fg between earth and moon, that's what we're going to find out. That will be gm1 m2 divided by r square. Again, G value is 6.67. 6.67 times 10 raised to power negative 11. That value is a constant number. Mass of the moon is given to us and in the data table, that is 7.35. 7.35 times 10 raised to power 22. 7.35 multiplied by 10 to the 22, and then the mass of the earth is also given to us, that is 5.97. 5.97 times 10 raised to the power 24 kgs, and then divide this by the distance between the moon and the earth, that is 3.84 times 10 raised to the power 8. So 3.84 times 10 raised to the power 8, and then square it. Now, once you reach to this point, up to this point, everything looks really simple, but the calculation in these kind of questions are the toughest thing where the students end up struggling. So I'll encourage you guys to, when you are putting these values in the calculator, to start with the bracket 6.67 times 10 raised to the power negative 11 multiply by 7.35 times 10 raised to the power 22 multiply by 5.97 times 10 raised to the power 24, close the bracket, then divide it by, start another bracket, 3.84 times 10 raised to the power 8, close the bracket, and then square it. Do not forget to square it, otherwise your answer will be wrong. That's how you're going to put it in your calculator. And once you're going to put these values in the calculator, you will get the number as 1.985 times 10 raised to the power 20 newtons. That's the force of gravitation between the earth and moon. In the same way, you will calculate how much force of gravitation which is being applied by the sun on the earth. So I'll put in the numbers for that. That will, again, I'll write down the formula gm1 m2 divided by r square, and that value will be equal to 6.67 multiplied by 10 raised to the power negative 11 multiplied by the mass of earth, which is 5.97 times 10 raised to the power 24, and mass of the sun, again I can go back and look into the given table, 1.99 times 10 raised to the power 30. So 1 point multiplied by 1.99 times 10 raised to the power 30. Again, make sure you put these values thoroughly in the calculator, otherwise you may end up struggling with the answer. 1.5, the distance, this is the distance between earth and the sun. So 1.5 times 10 raised to the power 11, close the bracket, square it, and then you will get the number as 3.522 times 10 raised to the power 22 newton. The previous force was 10 raised to the power 20 newton, and this force is way more than the force which is exerted by the moon. Now, but we wanted to find the resultant force. How we can find the resultant force? We're going to apply the same vector concepts in this one. If, let's say, I'm going to give you a simple concept. If this force is 10 newton and towards the right hand side the force is 50 newton, the net force will be equal to 15 minus 10, because this is towards the left hand side, you will call it as 5 newtons to the right. So same concept we will apply to this question also. We've already figured out the force, and the force exerted by the moon on earth, that was in the negative direction. So that will come out to be left and then this is towards the right hand side. So the net force, we will apply the vectors 3.522 multiplied by 10 to the 22 minus we will subtract the other force 1.985 times 10 raised to the power 20 newtons, and then we will get the final number as 3.50 times 10 raised to the power 22 newton towards the right or towards the sun. That's how we're going to solve it. Now that was pretty straightforward. That was pretty much an example of a one-dimensional vector problem. But sometimes you may have the question where, if let's say this is Earth and this is where the sun is and this is where the moon is. Now how are you going to solve it? And I'm going to keep the distance same between Earth and moon. That is 3 point. Oops, this distance is. Let me erase this. This distance is 3.84 times 10 raised to the power 8 meter, and then this distance is 1.50 times 10 raised to the power 11 meter. Again, the mass of the three identities will remain the same. In this question, how are we going to solve this? Again, this is a two-dimensional vector problem. Because the distance is same, mass of moon is same, mass of earth is same, so the force in the upward direction will remain the same. So I can cheat it from the previous question. The force exerted by a moon on earth, this it will come out to be the same. You can go ahead and do the calculation one more time. You'll find this will be exactly the same number, 1.985 times 10 raised to power 20. And same thing gonna stay with the sun also. And this force will come out to be how much? This will be the same as the previous one, 3.522 3.522 times 10 raised to power 22 Newton. And now I wanted to find the net force on the earth. So again, I'll use the vector concept. If let's say this force is 10 Newton, the upward force is 5 Newton. I wanted to find the resultant force. The resultant force will be in this direction. So this is what we are looking for. I'm going to replace this 5 Newton on this side, 5 Newton. I'm going to complete the right angle triangle and apply the Pythagorean theorem. All right, and that's how we will be able to find the answer. So same concept I'm going to about to apply to this one. So this vector, I'll replace it on this side. This is 1.985 times 10 raised to power 20. And I'm looking for the resultant, that is that I'm going to draw it with the pink color. Okay, that's what I'm looking for. So resultant or the net force on earth will be equal to square root of 3.522 times 10 to the 22 plus 1.985 times 10 to the 20 square, and then that's going to give you the final answer as 3.52 times 10 raised to power 22 newtons. And then you can find this angle theta also. How are you going to find angle? Tangent theta equal to opposite upon adjacent. Again, make sure once you're going to put this value in calculator, you use the brackets correctly. So theta value will be tangent inverse, start the bracket of your calculator, 3.522. The opposite is the smaller one, sorry, in this case. So this will be 1.985 times 10 to the 20 divided by 3.522 multiplied by 10 to the 22. Close the bracket and then you will get the answer. Make sure you don't miss the bracket, otherwise your answer will be wrong. So theta value will come out to be 0.3 degrees, and you can call it as 0.3 degrees north of east. All right, so this will be this angle north of east. All right, so that's how you can simplify these kind of questions. So hopefully now you are clear about how to calculate the force of gravitation. Now I'm going to go to